Good day, guys, and welcome back. Today we will do qualitative analysis. All right, we have this question. Says that the diagram below shows some reactions of alloy A. All right, given that alloy A can either be copper zinc or copper lead. Anyway, just take note. Copper zinc is your brass, and your copper lead is basically not a glamour name. Is normally known as leaded copper. Okay, so yeah. What is an alloy? Some students are still confused. Alloy is just a mixture of two or more elements melted together, and of course, at least one of them must be a metal. For example, we have iron plus carbon will give you your alloy of steel. Yes, yep, man of steel. Your Superman. Superman is strong because iron by itself is very weak. That's why Iron Man died. Anyway, that's what I told my student. It's easy for you to remember, isn't it? Yeah. Anyway, so that's one thing about alloy. So it's just a mixture. So it's easier to split them. So yep, back to our this one. It means alloy A. Take note. It can be copper and zinc. Alloy copper and zinc, which is your brass, right? Okay, you may want to remember this. Is very nice name. And of course it can also be copper lead, which is also known as a leaded copper. Oh, nice name. Anyway, so yep. And yeah, basically this one leaded copper normally used for your this anti-friction applications. Those kind of bearings. Yeah. Okay, that's one thing. Anyway, so when you add acid to your alloy, obviously something must be split into, yeah, and of course it will be split into your reddish brown solid M and colorless solution D. Why they have colorless solution D? Because you're having an acid. Yep. Okay. All right. So when we have acid and alloy, when added together, for example, when we have copper, well, basically, obviously copper do not it doesn't react with acid, right? So you will get your copper here. Okay, so your solid M must be copper. All right. Okay. So if let's say you're not familiar, well, basically, your this reactivity series that you have to remember. If you have not been told to remember, please remember now. You have your Posokamal Zil H cum. Okay, this is your potassium, sodium, calcium, magnesium, aluminium, zinc, iron, lead. H is for your H plus. We're representing your acid. Anything below here will be no reactions with acid. So your copper, your mercury, your gold, your platinum, yeah, it won't. You put thousands and tons and you dip dip into your this acid, it will just ignore the acid. Yeah, who cares? Acid, all right. But then of course your reactive elements, yeah, the metals, yeah, right, from potassium all the way to your lead, right, it will dissolve in the acid, right? Okay. Other than that, what else? Yeah, so that's one thing about it. And of course your colorless solution D here. Okay, so your colorless solution D has to contain your zinc or your lead, but then we were told is colorless, right? So obviously it can't be your lead, you know. For example, if let's say the acid is your hydrochloric acid, your this lead chloride, yeah, is insoluble in water, so it will be PPT, right? So basically here we already know that your this alloy here basically must be zinc and copper, right? But now, man, we just follow the what they told us to do, right? And we realized that this step 2, we are required to add nitric acid followed by aqueous silver nitrate. This step is actually to find for the presence of your iodide or chloride. Iodide will give you your this iodide here will produce yellow PPT, but your chloride here will be white PPT. Yeah. So that means obviously you filter it, you will get your white solid G, right? Anyway, some student will ask, where in the world I get my chloride from, right? Yeah, since we know it's a white PPT, because the step 2 already tell you that is to find the presence of iodide or chloride, and since white PPT is produced, of course your this white solid must be your Cl negative. Negative must be inside your white solid G, right? All right. Where in the world it is? Well, where it comes from? Obviously, it comes from the solid. I mean, sorry, the dilute acid B, right? That means your acid must be HCl bracket AQ. Please remember to put AQ for your acid is aqueous. That means it dissolves in water. Your solvent must be water, and of course, your this once dissolved in water, hydrogen chloride will be split into H plus and Cl minus. Yep, the property of an acid, remember? Yeah, strong acid, complete ionization. Yeah, okay. All right, so basically what we have is, right, when we filter, we get white PPT, solid G. That means solid G, basically must contain chloride, and it must be silver chloride. Where the silver come from? Ta-da! You have silver nitrate. Yeah. So this naughty silver must be getting partner with your chloride. Okay. So yep. So your Ag, right? Your Ag plus must come from your silver nitrate, and your Cl minus must come from your acid, right? Okay, that will be your solid G. All right. And after that, what happened? This when we filter, of course, we will get us the solid G, the dry one, and of course we will have the colorless solution L. And after that, what happened is that the step 3 they said add aqueous ammonia. Basically, as you know, aqueous ammonia is used to find the presence of cations, right? Okay, and when added with aqueous ammonia, we will get a white PPT. White PPT can with aqueous ammonia. Well, basically you should possibility is aluminum, right? Al, right? Al3 plus aluminum. You can be also be magnesium 2 plus ion, lead Pb2 plus, right? Or your zinc. It can also be zinc 2 plus. Okay, but only zinc will be soluble in excess aqueous ammonia. Therefore, the white solid J here, they say dissolve when you add excess aqueous ammonia. That means Juliet here must be your zinc. Zinc 2 plus ion must be present here. Yep, cool, isn't it? Right? It means obviously our alloy, right, must be copper and zinc. So the winner is copper and zinc alloy, which is your brass. Simple. That's all, folks. Thank you for watching. Bye bye. See you next time. Bye bye. Take care.